So AlloyBot is what we would call an autonomous, self-driving laboratory for alloy materials. And the idea is really quite simple. Think about cutting-edge technologies such as turbines and jet engines and nuclear reactors, or think of everyday consumer products such as jewelry or your truck at home. And all of these applications rely on alloy materials, and we could improve their performance if we had better alloy materials at our disposal. So we urgently need new alloys which are stronger, more durable, but at the same time more lightweight. We need alloys which can perform at extremely high or low temperatures, alloys which can resist aggressive oxidation and corrosion, or which can survive intense radiation damage. And the problem is that the process of developing new such alloys is extremely expensive and time-consuming. So in the traditional approach, we human researchers, we go into the lab and we manually prepare our alloy and we test its performance. But because we're human, we get tired very easily and we have to sleep, and we're slow overall and we make mistakes all the time. And so as a result, this process of developing a new alloy can in some cases take decades until you have a new alloy that can actually be commercialized.
So instead of making alloys with our own hands, we are building AlloyBot. So AlloyBot uses robotics, automation, and artificial intelligence to synthesize and test new alloys 100 times faster. So today, we would like to show you our first building block, our module for automatic weighing and automatic arc melting. Firstly, the automatic weighing module. So very much like baking a cake, our weighing module works together with a robotic arm to weigh out the ingredients for the alloys. So in our case, it's metallic elements like copper, titanium, aluminum, etc. Here, you can see the robot driving up to the weighing module, where it places a copper crucible, which will be used as a melting container later. Then for each ingredient, the robot picks up a weighing cup and places it on the scale. Now from the funnel above, you can see the ingredients in the form of metal pellets dropping into the weighing cup. For each ingredient, we have a dispensing system which sends these pellets down to the funnel. Then with each pellet, the weight increases until the target amount has been reached, and the robot retrieves the cup. Now, alloys usually need more than one ingredient. So the robot repeats this weighing process with a few more cups until all ingredients have been weighed out to the exact amount needed for the alloy's target composition. Once done, in the final step, the robot takes the cup one after the other and pours the ingredients into the copper crucible. This completes the weighing task. The robot picks up the crucible containing the ingredients and carries it to the automatic arc melting module. The robot places the crucible inside the load lock chamber, which acts as a gateway. And in the next step, the crucible will be transferred into the main chamber where the melting will happen. For this, a transfer mechanism inside the load lock chamber picks up the crucible, moves it over to the melting chamber, and inserts it into a water-cooled copper earth. The transfer mechanism retracts, and finally 4 electrodes move into position. Each electrode now generates an intense plasma arc, which heats and melts the pellets until they have mixed into a single droplet of liquid metal. Finally, the arcs turn off, the metal solidifies and cools down, and the electrodes retract. Now, to make the alloy more uniform, we have to remelt it multiple times. First, the mechanism returns with a scoop to flip the alloy upside down. And then the alloy is remelted to mix more thoroughly. And that produces a new alloy. To complete the process, the transfer mechanism retrieves the crucible from the melting chamber back into the load lock chamber. And finally, the robot retrieves the crucible and takes the alloy away for the next testing steps. Overall, this system will enable the AlloyBot self-driving lab we are building to autonomously synthesize over 150 alloys per week, and that is exactly the kind of acceleration we need.